Hello guys, I'm Nurse Shai. Today we're going to be discussing the Hesi square, the chemistry section. And guys, I'm so excited. I love chemistry. Now, this is not only for the Hesi square. This information is so basic that it can apply to anyone who is taking the Kaplan, who is taking the T's, which are both pre-nursing exams. If you're taking a college placement test, you can also follow this information. And also, if you're just about to start chemistry, this is basic information that it would be wise, I would say, in my opinion, to go over this video before you even take the chemistry course. But yes, let's get started. So please subscribe to this channel, guys. Like this video at the end and comment down below if there's something that you need clarification on, or if this video has helped you. This is going to be a long and very strenuous video, so please be prepared to take notes. Go get your tablet, your pens, your paper, everything that you need to take notes. I'll wait for you. Alright guys, so matter is anything that takes up space and has a mass. For example, a proton, atoms, a house, a laptop, you or matter. So there's some examples of matter. So mass is a measure of the amount of matter that an object contains. It's usually measured in grams and kilograms, and this is not the same thing as being weighed. That's a whole different type of measurement, okay? And this is so important because in chemistry, you do a lot of calculations and conversions. It's almost like taking a math course. It's like taking math and science and then just combining the two. That's what pretty much I summed it up as to be. Okay, so as you can see, we have an element, carbon here, and it's very, very simple. And I'm going to break down this different parts because I'm pretty sure this is on the test. So this number here is called the atomic number. And this number here is the mass. And once again, a mass is a measure of the amount of matter that's in the object, okay? So carbon has 12.01 something something of mass, okay? So what's in these different elements? I'm trying to make sure I talk pretty well, and I hope I explain myself pretty well for you guys. Okay, so what's in the atomic or the atomic number? It's just the protons. Wait, I probably should. No. And then what's in the mass is the protons and neutrons. And before I go any further, I have to like kind of break down like what atoms are. That's what I probably should have did first. So an atom, this is an atom, you know, and not the best drawn atom there is, but inside of an atom there is neutrons and protons. Scientific notation is a scientific way of writing very big or very small numbers easily. For example, we have 10 to the 9th power, and how I would write that, I would just write 9 zeros, put the 1 first, and then write 9 zeros. And that's how I would write that exponent. And then 10 to the negative 9th power, I would just write 9 zeros first, and then I would put the 1 after. And of course, you have to put your 0. You have to put a decimal in front of the first 0. I'm sorry, the second 0. And then so now I'm going to talk about the components of the scientific notation problems. I probably should have touched on that first, but I did it. So it's composed of 3 parts: the significant, which is 1.3, the mathematical sign, which is times, and the exponent, which is 5. You probably be asked to identify an exponent or identify the significant of a problem, or you may be asked to actually write out a scientific notation problem. So let's talk about temperature. So on your test, you might be confronted with a few questions that ask about, I just don't remember any of them, guys. I don't know, but in America we use, or the United States, we use Fahrenheit. We don't do Celsius as much, but it's just important to know like both of them. So the freezing water temperature would be 0 Celsius, and it would be 32 Fahrenheit. And then for the normal body temperature, would be 37 Celsius and 98 0.6 Fahrenheit. And these are things that if you're a prospect nurse, these numbers right here are not going away. They're not going away, you guys. You will always see these numbers. So boiling water is 100 Celsius, and then Fahrenheit it would be 212. So yeah, just want to put that out there. So this is also right here, this is the formula for converting Fahrenheit to Celsius and Celsius to Fahrenheit. I'm sorry y'all, it's been a long day. Okay, so this formula right here, as you can see, I'll just write somewhere, hope you guys can see it pretty good. This is going to be Celsius, that looks retarded, Celsius to Fahrenheit formula. And this one here is going to be the opposite, Fahrenheit to Celsius formula. Now there are more than one formula, you guys. I'll put that over here. You guys should see that. There's more than one formula, so you just do whatever or use whatever formula that you feel comfortable using. These are some formulas that I have memorized over the years and that I feel like I'm more comfortable using. It doesn't really matter which one you use because it's going to give you the same answer regardless. So I think on the test they may give you the formula. I'm not sure, but it would be nice. I just can't remember, but if I have to say, I think they gave it to you. So but if not, if you're not taking a Hesi, maybe you're taking a Kaplan or something, or you're taking another exam, I would like memorize these formulas, because if you want to be a nurse, you want to be a doctor, anything in the medical field or science field, anything in the STEAM field for that matter, this is not going away. So just have to put it out there. So I'm going to give you guys some examples. So a question will say like something like this. Okay, we'll do this one. Convert 68 Fahrenheit to, why do I always do that? Alright, so as you can see, hold up, this doesn't even look right, guys. I am so sorry. So as you can see, we've been given the Fahrenheit, so we automatically know that we need to use this formula right here because we're on the Fahrenheit to Celsius. So all we would do, we'll plug in this in our formula. Basically, we'll plug in this in our calculator, and usually they give you a calculator. If not, you know, maybe they let you have one. We'll just basically plug it in like this, guys. I hope you guys can see. We'll just do 68 minus 32, 5/9, give us 20. So 20 Celsius, or you can do the other one, the other formula. You can just put 32 minus 32 divided by 1.8, and it's going to give you 20 Celsius. Easy, right? Alright guys, now we're going to talk about ions and isotopes. So ions is when an atom is electrical charged. When an atom is in an ionic state, it will either lose electrons or gain electrons. So a cation is positive charged, and it actually gains protons and loses electrons, but that's not really important. And an anion, it is negative charge because it loses protons but it gains electrons. So these are two different types of ions, if I didn't make that mention. As you can see, the word already in there. Okay, so isotopes. Isotopes are atoms of the same element with different mass numbers. For example, you might be given a problem that are similar to this. And then we want to also keep in mind as I'm writing this, what a mass is, according to the definition I gave you guys not too long ago. So sometimes I just want to also mention this to you guys. sometimes they might play a little trick on you where they would put like the mass above the atomic number. They'll like, I remember seeing a problem like this, like no lie you guys. It was like, I think it was something like this, and it had like 598 at the top, and then it had like 91 at the bottom or something like that. And it was like, what is the number of neutrons in this product? It was like so really tricky because the numbers were big, and then they switched the atomic number and the atomic mass. But just know that, I hope you guys can see this, shucks. Just know that the bigger number will always be the mass, and the smaller one will always be the atomic number, because they do little tricky stuff like that, just to let you guys know. Okay, so back to the isotope example. So you definitely want to keep in mind, so we have the same element. These two are carbon elements, so they're the same element, so what, they have different mass. So do they have different mass? Yeah. And just in case you don't know, or you don't know for sure, you don't trust your judgment, you can always do some calculations, how we did earlier. How do we find neutrons? Because that's pretty much isotopes are. You just basically, you have different number of neutrons are mass numbers, so you would just like go 6 minus 12, that'll give you 6. And then here, because this is our neutrons, right? And I hope that makes sense to you guys. And then we would do the same thing to this problem here. Let me erase that. We would do 6 minus 14, which gives us 8 neutrons. So our mass, I could say mass too. This is a mass. So all the numbers different. Yeah, they're different. So this is an example of. Next we have chemical changes and physical changes. Now this is really easy. So let's go over what a chemical change is. A chemical change is an original substance that is transformed into a new substance with different priorities. So an example of a chemical change would be like burning of wood, and then that wood turning in wood turning in to ashes, because it's no way that it can convert back over to wood. It's just totally chemically destroyed. And a physical change is a transformation that does not produce a new substance. So an example of a physical change would be like cutting a slice, cutting some fruit, cutting a tree, things like that. Like, it's not like totally destroyed, but it's in a different form. But it's a physical change, but it's not a chemical one. So I hope you guys get the difference between chemical and physical change. So this would be more like something that just can't come back ever. It's done for. Like burning a piece of paper. But then this physical change would be more like tearing a piece of paper, cutting a piece of paper. It's still a piece of paper because you can glue it back up, you can fix it. But as far as burning it, there's no way it's coming back. And I just wanted to quickly mention, you guys, the mole. Now, I didn't see this on the Kaplan, but I just want to mention this just in case it is on there, or another test that you may have taken or about to take. So a mole is the amount of substance that contains 6.02 times 10 to the 23rd particles. It's an Avogadro number, so I don't really know if that's going to be on the Kaplan or the TDs or not, but I just thought I should just mention that for sure. Okay, so now we're talking about compounds and mixtures. Mixtures consist of 2 or more substances that are not chemically bonded. There are 2 main mixtures that they use in chemistry: homogeneous mixture and heterogeneous mixture. Homo means same, hetero means different. So homogeneous is a mixture that is uniform, distributed. An example of homogeneous mixture would be water, salt, because we know salt is, since this is chemistry, that's salt, table salt, that's why. But anyway, tea, Kool-Aid, things like that. So heterogeneous mixture is not uniform distributed. It's the opposite of homogeneous. So examples of heterogeneous mixture would be like pizza, a rock, You guys, my marker is going out. I need to find another one real quick. Vegetable soup, stuff like that. So I hope you guys get the difference. Homogeneous always reminds me of water. It's like all of these different things that I mentioned for examples. All the examples I mentioned, they're things that dissolvable, you know, like you really can't tell that there's sugar in your tea once you stir it up and it blends in. There's no way you can tell. It's unified. And then heterogeneous, I always use the example of pizza because it's like you have all these different elements on pizza. You have pepperoni, you have mushrooms, you have spinach, you have onions, you have all type of things on there, and you can actually see each element. And vegetable soup is the same way. Like you see the chicken, you see the noodles, you see the peppers, you see the onions. So it's like you see everything, so it's not uniform distributed. And I hope that example makes sense to you guys. All right, solvent, salute, and solution. It's good to know the differences. I don't remember seeing this on the Hesi for sure, but you never know what version that you might get. I don't know if there's like several versions out there or not. I don't know. So the solvent is the thing that does the dissolving, and it usually is water. Like, don't quote me on that, but I believe that it's usually water, because what dissolves better than water? Okay, anyway, a solute would be added to the solvent, which will be the person or the thing that's being dissolved. I see person, oh my god. This is the thing that's being dissolved. So the solvent and the solute together makes a solution, which is a homogeneous mixture that consists of these two things that we just mentioned. An example of that, a very common example, would be, let's say this is a cup of water. Let's say this is water, and we add water to, let's say this is some table salt. So we add those together to make some salt water. Then we end up with just some salt water, you know, which would not be very tasteful. And I suppose you could do the same thing like with if you were doing sugar water, you know, just like this would be sugar and it'll make sugar water. So it's the same thing. So that's the difference between solvent, salt, solute, and solution. Very easy stuff. All right, so periodic table. These are some fun quick facts, and then I'll show you guys the actual periodic table, because there's no way I could just draw it on this board. So the periodic table is arranged in groups and periods. The group numbers, they show how many electrons that are in the shell, and then the groups, they range up and down. I'll insert a picture there. The groups are up and down. And then the periods, they are left to right horizontally. So the heavy metals are at the bottom, and then the lighter metals are at the top. And I know we already talked about like the different atomic number and atomic mass, but this is also, the one in the middle is a chemical symbol for carbon, and that's how the periodic table is structured. Here's a better picture of the color coordinated periodic table. So the section is highlighted in yellow. These are the alkaline metals. The section is highlighted in purple. These are the alkaline earth metals. The section that is in orange, these are the transitional metals. The section that is right here, group 7A, these are the halogens. The group 8A, these are the noble gases. You might get a question on the test. They may ask you, oh, is this element here, or is silver, is that silver? Yeah, is silver a transitional metal? So you would say yeah. So that's why it's important to know these. People really don't focus about these two sections of the periodic table too much, but these are the lanthanides, the first row, and then the second row is the actinides. Another way these elements are grouped are by metals, nonmetals, and semimetals. So every element you see here in green, that would be the metals. The groups that you see in gray, that would be your metalloids or your semimetals. And then the elements you see in blue, that would be your nonmetals. So you guys go ahead and screenshot this, because this also might be on your test. And real quick, you guys, it's good to know the difference between solid, gas, and liquids. And I know that's kind of obvious, but it's good to just kind of know that. A solid would be like, you know, a person, a human. Gas would be like oxygen, air. Liquids would be like water, tea, something to drink. Just make sure you know the difference between the two. All right, guys. Stoichiometry. What is stoichiometry? It's the part of chemistry that deals with the quantities and numeric relationships of the particles in a chemical reaction. So first off, before we go any further, I just want to go ahead and mention to you guys, anything on the other side of this arrow, it would be the product, and everything that's on the left side of the arrow would be the reactant. Reactants are like ingredients. If you were cooking a cake, a chocolate cake, let's say you're cooking a chocolate cake, right? The reactants would be the ingredients. The flour, the eggs, the cocoa, the sugar, that's the reactants. The products would be the cake, the chocolate cake itself. So with that being said, we'll talk a little bit about balancing equations next, but right now we're going to go ahead and do this stoichiometry problem. Now, the way I do mine is not really considered the proper way, but this is a time test, you guys, and we don't want to spend too much time on it. If you want to do it the old-fashioned way, I'm going to show you how to do it both ways. But the way I would do this problem, I would do it, just off the top of my head and just writing a few numbers down instead of the whole entire freaking elements. I wouldn't do that. I just, that's just me. But don't listen to me. Do it the old-fashioned way. Anyway, let's read the problem. Determine the number of moles of oxygen that will react to 4 moles of ethylene, which is C2H6. So I would underline 4 because I'm a visual person. I have to kind of see stuff. So they're asking, we have to figure out, what are they asking? How many moles of oxygen that will react to 4 moles of ethylene? So how many moles of ethylene do we have right now? Well, we have 2 of them. So 2 ethylene, or C2H6, plus 7 oxygens made this our product. But they want to know how many moles of oxygen will react to 4 moles of this. So basically we just double it up. Like, chemistry is just like math, like doing an algebra problem. Just like doing an algebra problem. So it asks about oxygen, the moles of oxygen, and it asks about nothing over here. Nothing at all. So what I do, and what I did to solve this problem, I just add. So just forget this though. Forget that this is here. Forget that this is here. This is our oxygen. The 7 is our oxygen. Now don't forget that. Matter of fact, let me write it over here because I don't want y'all to forget this, because I don't break this down really, really good. Let me write it over here. This is the original problem. That's 7 oxygens that gave us the product of this. I don't want y'all to... That's our original problem. So y'all saw what I did, right? So basically, this is the ethylene. So they said how many? 4 moles of ethylene. So we did that, 4. And then basically that's going to give us 14 oxygen molecules, moles of oxygen. That's the way I do it. Very simple, easy, fast. And I'm going to show you the way that you're supposed to properly do it. Alright guys, balancing equations. Now, this is just, it's very, very similar to doing algebra. Like, don't let these element representations fool you. It's like the same thing as if you were doing a problem like this. 4x plus 5 equals 17. It's the same way. And that's how you have to look at chemistry equations like algebra. Okay, you would do what? First thing you would do, you would subtract 5 from each side. That will cancel out. And I don't know, that would give you 12. And then 12, yeah. It's the same thing. Okay, it's the same thing. So when you see that, don't even panic. Y'all got this. So let's get started. Same thing as doing an algebra problem. So what I was taught was, this is what you do, is how you approach a chemistry equation. You write out exactly what you have. We have 8 sulfurs in this equation. And there's an imaginary 1. I'm just going to say that. Imaginary 1 in front of each element, okay? So we have 8 sulfurs. We have 2 oxygens. Excuse me. And here, our product, we have 1 sulfur, but we have 2 oxygens. Now this is not a balanced equation because there's more sulfur than there on the reactant side than there is on the product side, and that is not correct. Okay, so how do we fix that? Well, we take the 8 and we place it here. And I'm gonna write with a different color. Alright, so we take the 8 and we place it here. But essentially, we're just doing 1 times 8. So since we put the 8 in front of this sulfur to balance it out, we'll have to add 8 over here as well to balance it out, because we can't, what we do to one side, we have to do to the other side. Okay, so you would multiply also the oxygen. See this right here needs to get multiplied by 8, because this 8, this coefficient in front of these 2 elements, also applies to this 2 here. So that gives us 16 as well. So if you look at the equation, you step back, this sulfur here on this side, on the product side, is an 8, and then the oxygen over here is a 16. The oxygen over here now is a 16, and then the sulfur over here is 8. So that's how you know it's a balanced equation. When you do this method, you pretty much know it. But sometimes you can just like see an equation and be like, oh, I know I need to add an 8. That's what I did. I did the product in my I did the equation in my head before I saw the actual outcome. But it's better to do, just write it out. That's how I was taught in chemistry, and that way you'll know that it's, you know, if you balanced it correctly or not, because each element is supposed to have the same numbers on each side. What is the molecular weight of ethanol? So the first thing you would do when you have a problem like this, they'll give you the molar mass or the mass of each element. But if for some reason you don't have that, all you would have to do is find the atomic mass of carbon. And just to show you guys on the periodic table, that's 12.01. And so you would just write that out. You have 2 carbons, just keep that in mind. And then hydrogen atomic mass is 1.008, and then oxygen would be 15.99, as you see on the periodic table. So all you would do is multiply and add. Because I have 2 carbons, I would do 12 times 2. That's going to give us 24. And I have 6 hydrogen, so I would have to add the 6 here, and then I can round the 15.99 to 16 just for the sake of this problem, and then that's going to give us our molar mass, which is 46. Okay, so what you need to know for the test is oxidation and reduction. Oxidation and reduction is collectively called redox. It involves the transfer of electrons from one element to another. Alright, so this is a mnemonic that is commonly used in chemistry. Rig, doesn't look like oil. Rig. It stands for oxidation is loss, and Rig stands for reduction is gain. So I'll just write that down. I can't write that out. Oxidation, obviously I don't have enough room, and I still remember this, and I took chemistry like, I don't know how many years ago, maybe like two years ago, and I still remember this mnemonic very, very clear. And let me tell you guys, this is definitely on the test. This is a test question right here. I remember it, and I probably got that one wrong, I don't even know. But oxidation number of any element atom is 0. Repeat that. The element that is in a natural state, the charge is 0. But there are only a few exceptions: hydrogen, bromine, oxygen, nitrogen, and fluorine. Or fluoride, whatever. Acids versus base. So one thing about base or acids, they're different from each other. Okay, they're opposites. The acids are corrosive to metals. They donate hydrogens, whereas the base, they denature proteins, and they are hydrogen receptors, meaning that they accept hydrogens from wherever. Now, I don't know in relation to why or what the question they're going to ask, but I think you should definitely pay attention to the table that they give you, the pH scale table, because I just don't remember any on the test. But I think I remember a question like, oh, what pH level is bleach or something like that. So it's just good to familiarize yourself with that. I'll leave it on the screen, you guys. So the acids, they donate hydrogen. And by the way, pH stands for potential hydrogen. So every time you see this type of chart, this type of scale, just automatically think hydrogens. And sometimes the base is called basic or alkaline. It's the same thing. Yeah. So just know a few of these for the test, you guys. Drinking water will always, pure drinking water is 7, and pH of 7, and the pH of 13 would be bleach, and the pH of 2 would be battery acid. Alright guys, so alpha waves is the emissions of helium. It passes through paper and skin, and you can see it demonstrated here. The beta wave is a product of decomposition of a neutron. It can pass through aluminum. And then we have gamma wave. It's very high energy, it's electromagnetic, it's very similar to X-rays, but it's more energy. It's very, 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 very penetrating. It can go through 7 feet of concrete and lead. Oh my God. And you can just demonstrate its power. You can just see the demonstration of its power right there. On the test, they might ask you what wave is the strongest, what wave is the weakest, and you can just see that pictured here. Alright guys, so you want to know your 4 macronutrients. I know this is kind of geared toward more like biology, but this is actually on the chemistry section. Like when I took it, I found that like there was like not only chemistry there, but it was like a little bit of math, like conversions there. But if you do the math section, you're good for is like the grams and kilograms and converting pounds to kilograms and things like that. You just of course multiply or divide by 2.2 depending on what you're doing. But anywho, this is something that they had, so I'll just go over it with you guys. So the 4 macronutrients are carbohydrates, lipids, nucleic acids, and proteins. And the one thing I want to mention about nucleic acids, that would be like DNA, RNA. Let me get another little. And then the carbohydrates, I made a section down here, guys. In the book, they had like different types of names for carbohydrate, which is sugar and starches. So I'm gonna go over quickly. It's very simple. Using saccharides, that just basically means sugar. This is mono. Mono means 1. Di means 2. Ogly means 3 of 6. Poly means many. So you might see something in like, oh, how many molecules of sugar does monosaccharide has? So it has 1, or you might, that's the 1, I'm sorry. You might see a question and say how many molecules does disaccharides have? You would say 2, because di means 2, and thus forth. And something I wanted to mention about, oh yeah, lipids. You always know you're dealing with lipids because of the cool molecule, which is carbon and 2 oxygens and hydrogen. Now, you always will see them together, guys. That's how I would know that I'm dealing with a lipid molecule. So just thought I'd throw that information out there. All right, so chemical bonds. There's a covalent bond and there's an ionic bond. There's several different bonds. We'll go over all of them shortly. But for now, let's go over covalent bonds. Covalent bonds are formed when 2 atoms share electrons. They're generally in pairs. That's the key word there, guys. So an example of a covalent bond would be H2O. And don't worry about what I'm about to do right now. So this is just like literally something to help you see. This is called a Lewis structure. and we learned this in chemistry. But anyway, I drew this out because I wanted you to see how these two hydrogen are sharing this one oxygen. That's water. So that's how you know if you come across or came across a covalent bond, because they're sharing electron. And generally it'll be like probably even numbers, since they're generally in pairs, right? So if you see even numbers, and if you see like, I don't know, something like this, that's peroxide, I believe, you know, it's still a covalent bond because the electrons, they share each other. Ionic bond is attraction between opposite charged ions, cation and anions. They're generally formed between a nonmetal and a metal. And so, as we learned earlier, this is a negative, and ions are negatively charged, and then a cation are positively charged. Oh God, that doesn't look too good. So that's how you know you have an ionic bond. And a perfect example of ionic bond would be sodium plus chloride, which would give us, but the point is, basically, this is a negative, that's a negative, a negative plus a positive. That's the perfect example of an ionic bond. So if you see anything like that on the test, then you know it's ionic bond. Intermolecular forces. So there are three types: hydrogen bonds, dipoid, and dispersion. So you might be asked on the test to name at least 3 or 2 or 1 of them. So it's important to know that. But let's start with hydrogen bond. Hydrogen bond is attraction for a hydrogen atom by high electronegativity elements. Usually it involves fluorine, fluoride, oxygen, or nitrogen. An example of a hydrogen bond would be if you see something like this, which is water, and one way we can identify a hydrogen bond, well, of course, it's going to have hydrogen in it. That's what that H stands for, hydrogen. And it might be coupled with fluoride. I'm going to call this one fluoride. That's not how you pronounce it. Fluorine, I believe. Oxygen or nitrogen. So it's going to be coupled with any one of them. So, but this one isn't. But this one has a hydrogen. So, you know, whatever. But that's how one way that you can identify a hydrogen bond is going to have hydrogen in there. Okay. All right, dipoid is the attraction of a dipoid, one molecule for the dipoid of another molecule. This is when electrons are unevenly shared. So dipoid is the attraction of a dipoid, one molecule for the dipoid of another molecule. This is when an electron is shared unevenly. Now this dipoid example I'm going to give you, it's kind of weird, but this is something that helped me understand exactly what it is. I just write that and I put that by dipoid. So what that is like an opposite attraction. It's like opposites attract. That's what I think about when I think about a dipoid bond. And this also is one. We used this one earlier. That's an example because it's like the opposites attract. And I've been trying to look for some more information on these types of bonds, but I'm gonna just say opposites attract. That's what I've pretty much got, all the information that I got for dipoid. For dispersion, this is when electrons concentrate themselves on one side of an atom, which causes a temporary, where do I get temporary from? Temporary dipoid. An example would be so one thing that has helped me to identify a dispersion bond will be the use of carbon and hydrogen. So if you see an answer or an option that has carbon and hydrogen in there, that's most likely is a dispersion. Like this one probably would be a dispersion bond. So yeah, if you see that, then you know that is that. In chemistry, there's 5 types of chemical reactions: syntheses or synthesis, decomposition, combustion, single replacement, and double replacement. Syntheses or synthesis is when 2 elements combine to form one product. The compound is made from simpler materials. 2 compounds form to make a single product. As you can see illustrated here, we have potassium plus chloride, and that gives us this particular product. It's just basically taking one product of a simpler term and combining them together. So we have carbon and oxygen, and together it collectively makes carbon dioxide. And then to further illustrate that, it's like A plus B, which would give us an AB. It's very simple as that. You might get a problem that asks you identify a problem that is a synthesis or a synthesis type of illustration or problem. Decomposition is the breaking down of compounds into component parts. This is the opposite of synthesis. For example, we have H2O. What a decomposition reaction does is break down the hydrogen, as we see here. It broke down the hydrogen and the oxygen separately. The next example we have is sodium chloride, and it really broke down the sodium and the chlorine apart. And to further illustrate that, if you had A and B together, a decomposition reaction will break down A and B as 2 separate components. A combustion reaction is a chemical reaction where oxygen and fuel react. It is literally the burning of gases. It will always contain CO2 and H2O as a product. That is one way you can quickly identify a combustion reaction. For example, everything on the product side is in orange and black to help you identify that this is a combustion reaction. And it doesn't really matter if it has a coefficient in front, which is a number in front of the elements or not. Long as you see CO2 and H2O, you know that is a combustion reaction. Simple. Okay, the next type of chemical reactions we have is single replacement. These are reactions that consist of more than one active metals reacting with ionic compounds, which means one element starts out by itself and ends up kicking another element out. So we have some examples here and also some illustrations to help you guys understand what a single replacement reaction is. So we start off with copper. We have silver, nitrogen, and oxygen, and then mix that up. And what happens in a single replacement reaction is copper switched with nitrogen and oxygen. And then we see silver alone by itself, which is represented right here. So in the single replacement reactions, the second reagent is the one that gets switched over. So it's like switching dancing partners or something like that. So here, this is an illustration I painted for you guys. We have red plus blue-green, which in a single replacement reaction gives us blue plus red-green. So basically, they just switched partners, and the second reagent switched with the red one. Same thing here. A plus BC gives us B plus AC. Basically, they just switched partners. You see how B just switched? Sorry. C was the one that switched with A. That's pretty much a single replacement. You might be asked to find which of these equations are a single replacement reaction. So that's how you know if the second reagent changes. So when you think about single replacement reactions, just think about one partner being switched, which is a second reagent, as we talked about later. Okay, so double replacements are reactions that involve 2 ionic compounds. The positive and negative ions in 2 compounds switch places. Everyone has a dancing partner, essentially. So we have silver with nitrogen and oxygen plus potassium and chlorine, and then that gives us, you see how these 2 switch partners? You see how they switch partners? That's pretty much what a double replacement is, unlike single replacement where it would leave like one of the reagents by itself. But in double replacement, everybody has a partner. As you can see, we have pink and blue together, and then we have red and green together, and then they just basically switch partners, because now pink is with green and then red is with blue. That's pretty much what you're looking for. If you are, this is pretty much what I use to identify a double replacement reaction. You might be asked to identify one on the test. All right, guys, so here we are with a example of a density, mass, or volume problem. Now this may or may not be on your test depending on what version you have. I don't remember seeing any on my test that I've taken, but you know, it doesn't hurt to know it. But I've did some research and some other people have seen some mass, volume, or density problems on their test, so it's better to know it than to not know it. You know, you're not going to get a lot of them. You're going to get like a few, maybe like 1 or 2 of them. So with that being said, we want all our points. We don't want to even miss one question on this test, because every little penny, every little question counts. So let's get to it. Now this is the traditional formula of density, which is D equals mass over volume. I don't really particularly like this one, but if you feel more comfortable using this one, go ahead. This is the one that we have been taught to use in chemistry. Well, we have the mass represented by the M, the D represented by density, and V volume. And the X in the between of density and volume is a multiplication symbol. And right here above mass or below mass is the division sign. And that would make sense in a little bit more time goes on. It'll make sense. Okay, so basically if you're asked to find your mass and you're given your density and your volume, then you multiply. If you have been asked to find your density, it'll be M over V, like this one over here. This works better for me if you're going to find either your density, mass, or volume. This works better. But if you're just finding your density, I guess this one would work better. But I don't really particularly like to use this at all. So if you were missing your, let's say you're missing your mass, I'll just say that. Let's get to the problem. All right. You have a lead ball with a mass of 420 grams. The density of lead is 10.5 grams / cubic centimeter. What is the volume of the ball? So this is what I like to do with all word problems, and I advise you to do the same. All right, so you go with your given a mass. What is a mass? I write stuff down. I have to, because I'm very visual, and sometimes I think my eyes play a little tricks on me. And then we're giving what else? The density, which is 10.5 grams / centimeter. All right. And that's our density. So you don't have to do this, you can skip this part, but like I said, this is something that I do so that I can make sure that I don't miss anything and write anything in the wrong place. Okay, so the question asks for what is the volume of the ball. So according to our precious little formula here, if we are given our mass and density, what will we do? Try to guess in your head before I say anything. If you guessed to multiply your to divide your mass and the density, then you're correct, because that's exactly what you do when you're looking for the volume. So we'll just go ahead and take 420, and it's important, guys, to write the unit measurement, because a lot of chemistry teachers and like those math instructors, they're very very strict on writing your unit. So 150, I'm sorry, I get 150 from. That's exactly why I write it on the side, because I'll be like making up numbers in my head, like what? Alright, see you guys. Alright, so basically we'll just divide that, and I'll do it at the same time you guys do it. So we get 40, and sometimes you might even have a tricky question, but I doubt that the Hesi is like tricky like that. You will cross out the grams, the grams cancel, and that leaves you with cubic centimeters. And that's the answer. Okay, so the next question says a loaf of bread has a mass of 500 grams and a volume of I'm going to say 2,500 centimeters, cubic centimeters. What is the density of the bread? It's supposed to be a question mark here. I'm not an English teacher. Anywho, obviously the answer is right there. So you would just do 500 grams over 2,500 cubic centimeters, and that would give you 0.2 grams / centimeter cubic centimeters. That's what that would give you. Because when you have a situation where you have 2 units, you just combine them. Very simple stuff. Thank you so much for watching this video. Please subscribe, like the video, comment down below. If you have already took Hesi and this video has helped you tremendously, share this video with your nursing buddies or anybody who you know need to brush up on their chemistry. I try my best, you guys, and I just wanted to contribute back to YouTube, because you know what, YouTube has done so much for me, and YouTube has literally saved my life. So save this video on your Hesi A square or your Kaplan or your T's or whatever exam you're taking playlist, because that's what I've done to pass my test, and I'm pretty sure you guys are gonna pass your test as well. And most of all, I gotta wish you guys good luck on the test, and let me know, how do you guys do? Let me know how you do. Bye.